So good day and welcome to my presentation on machine learning classification, surviving the Titanic using machine learning classification for prediction. Now, everyone knows the unfortunate story of the Titanic, so I'm not going to bore you with those details. Instead, I'm just going to go straight to some stats. Even though the ship was only at 53% capacity with around 1,317 registered passengers, only 38% or 498 people survived the tragedy. Given this, what are your chances of surviving the Titanic? Using machine learning classification methods and algorithms, my goal is to predict the survivability of passengers based on features in the data. The project itself will require some EDA, some feature engineering, a model building, and testing. I'll also employ some cross-validation, some fine-tuning of the hyperparameters, and then running the model against test data. In the end, I would eventually use the model in order to make predictions. And although the methods and techniques could be applied to real-life scenarios, such as risk assessment for insurance pricing for cruise ships or eventually space tourism and the like, ultimately, what I'd want to know is if I would survive the Titanic. To answer this question, I start with the data from Kaggle.com's Titanic survival dataset. The target value survived the straightforward with binary values, and others are a mix of categorical and numerical data. Now, looking at the data after some EDA, we can see some patterns that more rich females and adults with less or even no companions or family have higher survival rates. We could also see that people who came from the first port of Southampton survived more than those who didn't. So thinking back at my question, my chances of survival so far aren't looking so good. So the data set had missing values that needed attention. And to view these easier, I employed a library called Missing No, which created this plot and shows me missing values as white. We see them in 3 columns: age, cabin, and embarked. To deal with age, I took the mean or the average of the other ages and filled the missing values with it. For embarked, I used the mode or the most common value. But for cabin, given that there are too many missing values, I just decided to drop the column altogether. And to simplify things for my models, I opted to use label encoder to numerically encode categorical data, and I also dropped more columns that I deemed unnecessary. After getting the data to where I wanted it, I split the data into training, validation, and test sets. The first model I used was k-nearest neighbors, which has a single hyperparameter k pertaining to the number of neighbors close to the target. With a default value of 5 for k, the overall model scored 86. During the process of testing each model, I used sklearn's cross-val score for cross-validation. And using cross-validation k-fold CV, the training set is split into k smaller sets, and the model is trained using k-1 of the fold as a training data. The resulting model is validated on the remaining part of the data, and it spews out a score, as you can see. To tune the hyperparameter k, I created a function that ran the model with k values ranging from 3 to 15, then selected the k that had the most impact on overall scores. The ideal value of k, I found, was 3. And with that, the model scores improved slightly. The second model I chose was AdaBoost, or Adaptive Boost, which has 3 hyperparameters, and estimators, max depth, or the number of learners, and the learning rate. And using those default values, the base model scored 83%. Unlike KNN, tuning AdaBoost required more than one function to handle the number of combinations of hyperparameter values. Eventually, I got some values and I ran the model against the training data again. And with these optimized hyperparameters, the score certainly improved. And even though I employed k-fold CV, I still have validation data that I could use to verify how my model would perform against new data. Using the model on the validation data set also gave a slight improvement to the overall model score. However, other scores were closer to the non-optimized hyperparameter values. Against test data, the model score improved a bit more. But again, other scores were only slightly better. In the end, a model like this can be the starting point for, again, as I mentioned before, risk assessment for insurance companies to determine pricing and packaging for a travel industry. Overall, I was satisfied with the model, so I have to get back to my original question, which is, would I survive the Titanic? So to get a sample of people, I created some data that would be used for the model. I'd be in the second-class cabin paying an average fare and traveling alone. And the others in my test are females of different ages and have different family, traveling, and financial situations. So given this, who would survive my model? Using predict_proba on the model using these 3 cases, I was able to determine that, unfortunately, I didn't make it. and neither did the senior lady in third class. The rich single lady in first class survived, though, which is more realistic and is on par with what the actual data would suggest. This concludes my presentation, and thank you for your time.